So we're a little out of order now, but you guys go ahead.
All right. Hello, my name is Jake Temritzky.
I'm Gabrielle. I'm Crest. And I'm Samantha with this.
And what we created is called the Caspi Pod. So what we set out to do was lessen the death of plants caused by over or underwater. Excuse me. Our research showed that people everywhere across the country and across the world have issues keeping their plants alive, either because they're overwatering them, they're underwatering them, they're just having problems telling when's the appropriate time to water and how much water is needed. So what we came up with was a two-pot system that had a reservoir and would essentially water itself. So what you're seeing here is the inner pot that would contain the actual plant. This is how, that rim there is how it attaches to the outer pot, which holds the water. And they fit nicely together, like so. And as you can see, Sam is holding what we created. Now the research that went into this showed, like I said, that plants were dying because people couldn't tell when they needed to be watered and how much they needed to be watered. There are solutions out there that deal with this problem, and many of you guys may have seen them in infomercials and all kinds of crazy 1995 ads and things like that. Our research showed that a lot of these smaller solutions that are used in household plants don't work the way they're advertised and don't work sufficiently. There are other systems that work on outdoor plants at on larger scales that are very effective, but because of that, we decided to focus on indoor house plants only.
So once we had everything set, we decided to keep track of ourselves by creating this Gantt chart, which we went from every month and said, okay, we're going to get this done, then that done, then that done, and so on and so on. And on the next slide, we had our final Gantt chart, and as you can see, we were pretty much on track in the beginning, but as we got to the end, we got off track a little bit due to some problems that we had with printing and also everything else that we had to do during this whole time.
So here we have some other solutions that could solve the problem, but they weren't quite right. For instance, here we have the Oasis Indoor Automatic Drip System, and you would think it would work. However, we thought it would be very cumbersome to have all these tubes connected to all these different plants, and you have this gigantic square sitting on your wall. And the problem we saw with the aqua is that here, because it's so dry, when you fill it up and then place it into the pot, it would empty automatically. And another thing that we saw was that a lot of these systems were meant to connect to the pot. They weren't the pot itself. So we decided to go that route and see what we would find. And here we sent out a survey to the local area to see what kinds of problems they were having with their plants, what symptoms their plants were showing, whether it was wilting or overwatering, and there was weeds in their garden or in their pots. We also over here, a lot of people do have trouble determining how much water their plant needs because the yellow leaves can be both for the dry plants and for the overwatered plants. So they wouldn't always know if it was being overwatered or underwatered.
Okay, so when it finally came time to start our brainstorming, this is actually Jake's drawings, and the first drawing up top is actually just the drawing of the drip system, which is what we ended up using on our final product. And as you can see, it goes around the rim of the pot, and it goes up through a tube, which is, like I said, what we use. And it evenly dispenses the water into the soil, on top of the soil, instead of, in the middle, or like the water girl does it at the bottom. The second one is actually not the watering, but it was an alarm system. We decided that if we were going to use a pot, we needed to know when the reservoir was running out of water. So there's a sensor around here that tells you when it's running low, and this would either beep or light up, and that's when you know that you have to refill your pot. This is Kaylee's drawing, and this is a different concept that we really never would have thought of. There's actually sponges right here, and those sponges are actually full of water, and as the soil needs it, it dispenses it into the soil on top and down by the roots. And this is actually, once we actually had our final design, it's actually a drawing of how the root on the outer pot would be, so it would connect to the inner pot. And that's just pretty much how we decided that it would fit. For our decision matrices, the top one is our problem statement, and that's kind of how we decided what our problem really was going to be, whether we needed to focus on overwatering, underwatering, or really what the problems of the plants had. We rated them on a scale of 1, 2, or 0, and 1. Then we added the tallies up depending on the different criteria, and whichever one got the total is the one we ended up using. For the bottom, it was what we really needed to focus for our pods. We had the way if it was supposed to be light, heavy, it had to be mobile. It had to be, it had to fit in the house. It had to be pretty. And then we graded those on a scale from 1 to 5, or different scale system. And then we added them up, and that's how we ended up picking what really was the most important that we needed to add to our plan.
All right, so, excuse me. Our prototype is made up of a couple different components. The pump that actually moves and pumps the water is a catted drinking fountain pump. So it's from the little watering fountain that's for your cats. We just order a replacement pump and use that. We use some 3/8" tubing to transport the water. We use a digital moisture meter, and that's what actually reads the moisture of the soil to determine when water needs to be dispensed. And then we used our 3D printer and the printer material to print up our prototype. If we were to take this product to market, we would come up with a different way to create the actual pots. We wouldn't use a 3D printer because we actually discovered that it's not watertight, the product that's printed, and it's also not cost effective and time effective to mass produce something. So like I said, our prototype was printed in a 3D printer. It takes roughly about a day to print with the material. It's just ABS plastic and it layers it on, and it's actually really interesting to watch. We inserted our pump into the outer pot. We ran the cord through a hole on the outside so it can be plugged into the wall. Then we ran our plastic tubing that carries the water into the inner pot, and then wrapped it around the inside to create the soaker system that would actually evenly water the plant. And then finally, the inner pot is inserted into the outer pot to create our